Okay, so we ready to go there? Yes, we are. Okay, so our review, again, has 12 questions, and we're going to go through this at a leisurely pace. I want to get through at least half of it today. Okay, so if you remember, there's 4 sections in this chapter. The first section was solving right triangles. Second section was solving triangles with law of sines. Third section was the law of cosines. And then the fourth section was what we just did the other day, and that was not solving triangles, but finding the area of triangles. I will give you some formulas. Some of them I'm not going to give you though, okay? And I'll let you know which ones, okay? So we look at question number 1. They give us a triangle, and they give us theta, and 5 and 7, and they ask us for all 6 trig functions. So sine of theta, cosine theta, tangent of theta, cotangent, secant, and cosecant of theta. Okay, so I mean, you got to know SOHCAHTOA. I mean, if you know SOHCAHTOA, this is easy. If you don't know SOHCAHTOA, then it's next to impossible, okay? So we're talking about theta right here. Oops, they don't, do I give you the other side? No, I don't, okay? So in order to find out what this side is right here, we need the Pythagorean theorem. So 5 squared plus 7 squared equals c squared, or x squared, or a squared, or whatever squared, it doesn't matter. So we have 25 plus 49 is c squared. Add those together, you get 74 is c squared. So c is radical 74. Okay, and sine, again, SOHCAHTOA, S-O-H-C-A-H-T-O-A. So sine, and we're talking about this angle right here, the one that I labeled. Is that the right one? Yes, it is. Opposite over hypotenuse, so 7 over radical 74. I'm going to write that down, but that's not an acceptable answer. We have to get the radical off the bottom. Times the top and bottom by radical 74, we're going to have 7 radical 74 over regular old 74. Okay, for cosine is adjacent over hypotenuse, so it's 5 over radical 74 times our radical 74. You're going to have 5 radical 74 over 74. And tangent is opposite over adjacent, so 7/5. Cotangent, flip tangent, so it's 5/7. The reason why I wrote these, even though these are not the actual answers, these are the final answers, is I don't want to flip this one, I'm going to flip this one. Because if I do that, I'm done. It's going to be radical 74 over 5. And same thing with cosecant, radical 74 over 7. Okay, hopefully that's a pretty easy, straightforward one. Okay, number 2 and number 3, it says find the exact value, no calculators. So, I mean, I'll be right up front with you guys right here. You're going to need calculators on this test. Could you sneak in and do this one without a calculator? You can't. I mean, I'll never know, but you shouldn't have to, okay? As long as you remember this. When I went over this, sine, cosine, tangent, cotangent, secant, and cosecant. Some of these are cofunctions. Sine and cosine are cofunctions. Secant and cosecant are cofunctions, and tangent and cotangent are cofunctions. And what I taught you was that complements of cofunctions are the same. Complements not like good job, you know, way to go, not that kind of compliment. Complement meaning they add up to 90 degrees. These are complementary angles, 18 and 72. Tangent and cotangent are cofunctions. So that means they're the same thing. So if I subtract 2 things that are the same, you get 0. You shouldn't need a calculator for that. So on test day, you know, in all honesty, on test day, could you use a calculator? If you really want to, you can. But don't ask me how to type. If you ask me on a test, how do I type? I'm not sure how to type that in a calculator. I'm not going to tell you because you shouldn't need a calculator for that. Okay? Same with number 3. Secant 55 over cosecant 35 degrees. Okay? Those are also complementary angles. 55 and 35 add up to 90. Those are complements. Okay? Secant and cosecant are cofunctions of each other. Therefore, I don't know what the secant of 55 is, and I don't know what the cosecant of 35 is, but I know they're the same. And when you divide something by itself, you get 1. You shouldn't need a calculator or even have somebody work on that one. Okay? Question on those ones. Okay. Now, this is what's interesting. And this happens every year, and I'm guessing you guys are probably no different than any other class. When you're looking at number 4, some of you might be tempted to use the law of sines. And I'm not saying you can't. you can use the law of sines to solve number 4 and possibly, well, could you use the law of sines? I tell you what, not to put you on the spot here, but we'll just say I want you to know this. Could you use the law of sines on number 5? You could on 4. You definitely could on 4. Could you on 5, do you think? See, well, you guys remember the law of sines. There's no way you can use the law of sines on it. Why? Anybody know? The reason why you could use the law of sines on number 4 is you know capital B and lowercase b, okay? You use the law of sines when you know both the angle A and side A, or angle B and side B, or angle C and side C, okay? So on number 5, do you know both A's, both B's, or both C's? None of them. You can't use the law of sines, okay? Now what I'm getting at though is this. You can use the law of sines on number 4. You could use the law of cosines on number 5. You could. But what I taught you was you use the law of sines and the law of cosines to solve non-right triangles, okay? So you don't need to use those because 4 and 5 are both right triangles. I mean, they tell you. You see on 4, C, both 4 and 5, C is a 90-degree angle, okay? So what I'm getting at is this. If you really want to use the law of sines on number 4, you can. I'm not going to. That's not the way I taught you, okay? I use the law of sines and the law of cosines to solve non-right triangles. So if you're sitting there going, I don't remember how to solve this, well, that's why we're reviewing, okay? So was this A, B, and C? Is that the way it's labeled, I think? So we got to find little b and little a, okay?
That one, let's see it.
Yeah. Do I have them backwards? Oh, yep, thank you. C, B, nope, that's be a little c then. Okay, and that's one more thing, and only you know if you watch the videos or not. Where do you always find angle A at on a triangle? Not necessarily. Okay, I told you to put A on top. I told you to put that. Okay, compare angle A and side A. Where are they at? Opposite from each other. They're always across from each other, okay? If this is capital C, here's little c. Here's capital A, here's little a. I told you when you were solving non-right triangles to put A on top, just so it's easier for me to grade if you all have the same, they're all in the same spots. Okay, it's not wrong to put A at the bottom, but that's just the way I prefer to do it, okay? All right, so what, we gotta find capital A first, that, not necessarily first, then little a and little c. What would be the easiest to find first, capital A, little a, or little c? What's that? Capital A, you should be able, capital A you should be able to done back in middle school, okay? All 3 angles have to add up to 180. And if this is 90, these two together have to add to 90, so I'm not even gonna show my work on that. A would be 70, are we good with that? I didn't show my work. They have to, on a triangle, if one's 90, the other two together have to add to 90. If that's 20, that's gotta be 70, okay? So, we have to find little a, and we gotta find little c. It doesn't matter which one we find first. I'm gonna find little a first, okay? Now, which angle do we have to use, 70 or 20? It actually doesn't matter. It really doesn't, okay? I would avoid using the 90 for several reasons. If you remember on our unit circle that we're done with, at 90 degrees, you guys remember what the tangent of 90 degrees is? Up at the top here, remember that unit circle? It was 0, 1, and tangent was? It's not a number. And not only that, if this is the angle right here that we're using, what is this side right here? I mean, it's C, but it's what? This angle, this side is, it's the hypotenuse, and it's also the opposite. It can't be both, okay? So avoid using the 90-degree angle, okay? Just avoid it. So we have to use either 20 or 70. I'm going to use 20. It doesn't matter. It's not like one way is easier or harder than the other. It really doesn't matter, okay? So if I want to find out what little a is, okay, I want to find this. And what other side am I going to use? Am I going to use the hypotenuse, or am I going to use this side over here? What do you guys think? Do you think I'll use the hypotenuse or this side?
This side with the 5.
Yeah, why wouldn't I use this? I don't know. You can't have 2 things you don't know. You only have 1 thing. So these are the 2 sides I'm going to use. So if we use this angle, what trig function am I using? This is what? Opposite and adjacent. So I'm going to use what? Tangent. Tangent of what? 20 degrees equals opposite 5 over little a. I'm going to put you guys on the spot here. I'm going to find out real quick who watched the video and who didn't watch the video. I showed you a little trick here.
I'll tell you right now, probably not.
Probably not you? Okay. I showed you a little trick here. How do I solve this thing? I have A on the bottom. Anybody know what they do?